8.4 Properties of rhombuses, rectangles, and squares. Rhombuses, all four sides are equal. Rectangles, all four angles are equal. And square, it is both a rhombus and a rectangle. Alright, let's go ahead and draw these in our notes. Starting off with the rhombus. The rhombus is all four sides equal. So if I pull up my little diamond tool, then I can have a rhombus. Notice a rhombus is a parallelogram. We just don't have constrained angles. If it were 90 like this, it would be a square. Let's go ahead and put this, move it over on the side. Now let's go ahead and create our rectangle. A rectangle of any size, notice it's 90 degrees. If I hold down Shift in most programs, it makes a square. Yes, so we have our rhombus, rectangle, and our square. Go ahead and draw what you see, please. Then let's mark it up. So we have our rhombus, we have our rectangle, and we have our square. Now a rhombus, by definition, has all four sides equal. A rectangle doesn't necessarily have that, but it does have the 90 degrees. And a square is both a rhombus and a rectangle. Awesome. Let's keep going. Alright, let's say we got rhombus QRST. I want you to be able to tell me if it's always, sometimes, or never true that angle Q is congruent to angle S. Let's go ahead and create a new rhombus, because we need to draw this out in order to be able to determine if that's true. Now, when identifying your sides, let's make this a little less square-like, even though a square is a rhombus. When making your angles, note that you have to go around either clockwise or counterclockwise, one way or the other. So I'm going to choose to start with this, Q, and then I've got to do R, S, T. Never cross over like this, Q, R, S, T. No, we're looking to see if it's always, sometime, or never that Q is congruent to S. Notice these angles are opposite each other. A rhombus is a parallelogram, so this isn't always true. Let's say I was looking if Q was congruent to angle R. Notice Q and R are next to each other. They have to be supplementary because remember this is a parallelogram. And if they're supplementary, that means the only way they could be congruent is if they're both 90. And the only way that is if it's a square. So this is a sometimes. So always here and sometimes here. Alright, go ahead and draw what you see. We have a rhombus, and I put the statement here, perpendicular bisectors, to help you recall what we're doing here. We have a rhombus. I'm going to draw some diagonals connecting the opposite vertices, which is what a diagonal is. And we're going to work out a property of rhombus. In fact, I'm going to switch over to Sketchpad, and let's go ahead and create a rhombus using this theorem. I think that'll be best to understand what's going on. Now, if you remember from parallelograms, diagonals bisect each other. So I'm going to create a midpoint right there in the middle. Then I'm going to create a perpendicular line because bisectors are perpendicular. So now all I have to do is take this, start with somewhere on this line, create that, create this, and to make it a rhombus, all of these segments are going to have to be congruent. So let's go ahead and take both of these and flip it about this line, called reflection. That is our new rhombus. So I'm going to take these and make them dashed and put them back in the other program. Alright, let's go ahead and use the fact that this is a rhombus, or excuse me, that this is perpendicular and that this is a parallelogram, and let's prove that it's a rhombus. If it's a parallelogram, then opposite sides are parallel. And let's use the fact that this is 90 degrees and that diagonals bisect each other because it is a parallelogram. Let's use those facts to prove that this is a rhombus. Notice if this is 90, this is 90, and this is 90, and this is 90. So by side, angle, side, each of these triangles is congruent. And if they're congruent, then all of their corresponding sides are congruent. In this case, all of the hypotenuses of all four triangles. Awesome. The next theorem about rhombuses has to do with their angles, or their bisected angles. So go ahead and draw this rhombus again, and let's mark it out together. First of all, we know that it's a rhombus, so opposite sides are in fact parallel. And I think for this time I'm just going to state the points, and we'll talk about it more later. But the rhombus, it is a rhombus if and only if its diagonals bisect the opposite angles. We'll just write a little note here to help us remember. Awesome. The next image has to do with whether or not it's a rectangle, not what I wrote. Okay, I'm going to start with the fact that this is a rectangle, and then I'm going to put it in a coordinate plane, which we have here, with our origin as one of the points, with some unknown value. We'll call it A, but the y value is 0. Some unknown value for y over here, but the x value is 0. That means this point is A, B. Using a coordinate proof, let's go ahead and prove that these diagonals do in fact not only bisect each other, but are congruent using a coordinate proof. Now to do so, to say that this is a bisector, I need to find the midpoint of both of these segments. If the midpoint happens to be the same for both, then I should be able to find or prove that they do in fact bisect each other. Alright, so let me go ahead and clean this up a little bit. Alright, so let's find this midpoint using this line first. Notice the midpoint is A plus 0 divided by 2, and then B plus 0 divided by 2. That's that one. Now let's go ahead and do it for this line. Notice this line is A plus 0 divided by 2, and it's B plus 0 divided by 2. We get the same exact coordinates using two different variables, which implies that this point must be the same point for both lines. Which means that if it's the midpoint of this line, and this one's the midpoint of this one, then it has to be the midpoint of both lines. Therefore, it's the same point, and a rectangle has diagonals that bisect each other and are congruent. Alright, I'm going to go through a few problems. Number 3 says, for any rhombus JKLM, decide whether the statement is always, sometimes, or never true. Always, and I'm going to do different colors here. Sometimes, actually let's just do the S, and never true. Always, sometimes, never. Alright, we're told that angle L is congruent to angle M. We have the rhombus JKLM. So note I went around the rhombus JKLM. L is congruent to M. Notice L and M are next to each other. The only way that can be possible is if this is also a square. So this one's going to be a sometimes. This time, on number 9, we're told that angle W is congruent to angle X. And we're asked if that's always, sometimes, or never for rectangle WXYZ. So I'm going to draw WXYZ, WX, Y, and Z. W and X, well obviously this is a rectangle, so I probably didn't even need to draw it to be able to analyze this. This is an always because the angles inside of a rectangle are always 90. Okay, number 19 says, the directions say, name each quadrilateral, parallelogram, rectangle, rhombus, or square. We have to pick which one of these is true for this statement. It's equiangular. Obviously rectangles are, and since squares are also rectangles, both of these are true for this one. Okay, at number 27, we're asked to classify what type of quadrilateral this is. Also, go ahead and solve for values of x and y. We'll go ahead and clean this up. Note that if it's a parallelogram, which this one happens to be a rectangle by most specific or special name, unless these all prove to be equal, which we'll find here in a second, then it'll be a square. But we do know that the opposite sides are definitely equal. So we can go ahead and set up two equations and solve. In fact, go ahead and set that up and see if you get the same values I do. Okay, I got 10 and 20, If I plug in 10 to this, 10 plus 31 is 41, and 20 to this is 80, plus 5 is 85. That means that these two sides are not equal to these two sides, so it's only a rectangle and not a square.